Hi students. So in last video lecture I started a problem of equal angle section. Okay, for this problem we have to calculate stresses at points A, B and C. Point A, B and C, and the deflection of the beam at the midsection and the position of the neutral axis. This problem comes under the topic unsymmetrical bending. Okay, so in this problem I calculated the coordinates of centroid G. Okay, so G is the centroid for the total figure. Okay, so coordinates x bar and y bar I calculated as 23.6 mm, and similarly I calculate moment of inertia about xx axis Ixx. Okay, that is 8.98 into 10 power 5 mm per 4. Since it is equal angle section, Ixx is equal to Iyy. Okay, up to this I completed in the last video lecture. Okay, so after this we have to calculate coordinates of G1 and G2. Okay, so coordinates of G1 and G2. G1 is nothing but centroid for the portion 1, and G2 is the centroid for the portion 2. Okay, so G1 is equal to, okay, with respect to G only we are calculating. So coordinates of G1 with respect to G. Okay, we know G. Coordinates of G, x bar is 23.6 mm, and similarly y bar is also 23.6. Okay, with respect to G, coordinates of G1. Okay, so G1 is 80 divided by 240. Okay, so with respect to G, G is for G, x bar is 23. So G1 is ahead of G. So therefore positive value will come. So 40 minus 23.6. So 40 minus 23.6. Okay. So after this is the x value. So after calculating x value for G1, we have to calculate y value also for G1. Okay, so y value, so y bar for G is 23.6 mm. Okay, so this distance, so remaining distance. So G1 when for y value for G1 is behind the value of G. Okay, so y bar value for G is 23.6. So 23.6 minus 5. Okay, so they are written here. So plus value, x value is plus. So 40 minus 23.6 comma y value will come minus, because the G1 is behind the G in y direction. So minus of 23.6 minus 5. So x value for G1 is 16.34 and y value for G1 is minus 18.66. Okay, so I know I hope you understood. So G1, so x value is ahead of G. Okay, so in x direction G value is 23.6, G1 is 40, so 40 minus 23.6. so because G1 is ahead of G, so we are getting positive value. In y direction G value is 23.6, G1 value is 5. Okay, so here the value of y for G1 is behind the G, behind the value of y bar of G. Okay, so it will come minus, so minus of 23.6 minus 5. Okay, so after calculating coordinates of G1, okay, now we are calculating coordinates of G2. So G2, okay, so G2 in x direction and y direction with respect to G. So with for G, x bar value is 23.6 mm. For G2, for portion 2, the x bar value is 5, 10 divided by 2, 5. So it is also behind the G. So G2, the x value of G2 is behind the x bar value of G. So minus value will come. So minus of 23.6 minus 5. Minus of 23.6 minus 5 comma y value I have to calculate for G2. Okay, so for G2 the centroid is in y direction is portion 1 10 plus 70 by 2, so 35. So 10 plus 35 45. So 45 is head of y direction of y value of G. Okay, so y value of G is for 23.6. Here it comes 45. So 45 minus 23.6. So positive value. So 45 minus 23.6. Okay, so the x value of G2 is minus 18.6 and y value of G2 is plus 21.34. Okay, so after calculating coordinates G1 and G2, we have to calculate product of inertia IXY. Okay, so IXY is equal to the area of portion 180 into 10 into x value of portion coordinate G1 16.34 into y value of G1 minus 18.66. Okay, so you are multiplying these values plus portion 2 area 70 into 10 minus x coordinate of G2 minus 18.6 into y coordinate of G2 21.34. Okay, so we are getting the value as minus 5.2266 into 10 power 5 mm power 4. Okay, so after calculating the product of inertia, now we have to calculate theta value. Okay, theta is the inclination of the principal axis with the gx passing through G. Then tan 2 theta is equal to, I already gave this formula, tan 2 theta is equal to 2ixy divided by iyy minus ixx. Okay, so we know ixy value, iyy and ixx value and all. Okay, ixx is equal to 8.898 into 10 power 5 mm power 4, that is equal to iyy because it is an equal angle section. Okay, so iyy minus ixx means the same value, so 0. So anything divided by 0 is infinity. So tan theta is equal to infinity. So for which value will get infinity means tan 90. So tan 2 theta is equal to tan 90. So tan will cancel. So therefore 2 theta is equal to 90 degree. So therefore theta is equal to 45 degree. Okay, so theta 1 is equal to 45 degree and theta 2 is equal to 90 plus 45 is equal to 135 degree. Are the inclinations of the principal axis GU and GV respectively. So GU axis. Okay, so theta 1 value, this is the theta 1 45 degree and theta 2 with respect to GV. So GV, so this angle. Okay, so this is 135 degree, theta 2. This one is theta 2, 135 degree. So after calculating theta 1 and theta 2 and all, now we have to calculate principal moment of inertia. Okay, principal moment of inertia IUU. I already gave the formula. IUU is equal to 1 by 2 into IXX plus IYY plus 1 by 2 into IXX minus IYY into cos 90. That is theta 1. Okay, 45 degree. Okay, so cos 2 theta in the formula we'll have cos 2 theta. So 2 theta means 2 into 45 cos 90 minus IXY sin 2 theta. So theta is 45, so sin 90 degree. Okay, so we know IXX, IYY value and all. After substituting IXS, IYY and we are after simplification, so we are getting IUU as 14.1246 into 10 power 5 mm power 4. Okay, we know that IUU plus IVV is equal to IXX plus IYY. Okay, I already mentioned that the sum of moment of inertia of about principal axis is constant. So sum of moment of inertia about principal axis IUU plus IVV is equal to sum of moment of inertia about principal axis IXX plus IYY is also constant. Both are same. So IUU plus IVV is equal to IXX plus IYY. By using this equation, we are calculating IVV because we know IXX and IYY and all. So IVV is equal to IXX plus IYY minus IUU. Okay, so we are getting IVV as 3.67 into 10 power 5 mm power 4. Okay, so this is one method for calculating IVV. I already gave one formula for IVV in the last video lecture also. Okay, by using that formula also we can calculate IVV. So anyway, so IVV is 3.67 into 10 power 5 mm power 4. Okay, so after calculating principal moment of inertia, now we are calculating stresses at points A, B and C. Okay, so in the question itself they gave carries a load of 400 Newton at the centroid. Okay, they are at the centroid of the section. So they are also asking stresses at points A, B and C at the midsection of the beam. Okay, so bending moment at the midsection. we know the formula. Simply supported beam point load is acting at the center means the bending moment formula is WL by 4. So WL by 4 is equal to, we know the value of WL. So W 400 Newton into L 2.4 meter, we are converting it as a mm, 2.4 into 10 power 3 divided by 4. So we are getting 2.4 into 10 power 5 mm. So after calculating m, now we are calculating m dash. Okay, so we know the bending stress formula. I already shown in the last video lecture. So bending stress sigma B is equal to m dash u divided by IVV plus m double dash V divided by IUU. So by using this formula only we are calculating. Okay, so in this formula m dash, okay, so the component of m dash is m sin theta. Okay, so we calculated the value of m as a 2.4 into 10 power 5 Newton mm. Okay, so m dash, the components of bending moment m dash is equal to m sin theta. So 2.4 into sin theta. Okay, 2.4 into 10 power 5 into sin theta. Theta value 45 degree. So we are getting m dash as 1.697 into 10 power 5 Newton mm. Similarly, m dash is equal to the component of m dash is m cos theta. So 2.4 into 10 power 5 into cos 45 degree. We are getting the same value, 1.697 into 10 power 5 mm. Okay, so after calculating the components m dash and m double dash, now we are calculating the coordinates for UV. Okay, at point A. So point A, x is equal to minus 23.66. Okay, so point A is at here. Okay, so x for G. Okay, for G the x bar value is 23.6. So for point A means minus 23.66. Okay, then y value. So y value for point A. Okay, so y value is for point G is 23.6. Okay, from here. Okay, G, the y bar is 23.6 from the base BX1. Okay, point A is at the top. Total height is 80. So 80 minus 23.6 will get the y value for point A. Okay, so 80 minus 23.6, 56.34 mm. So this is the coordinate for point A. Okay, so for calculating the u, the formula is x cos theta plus y sin theta. Okay, this is simple formula only, x cos theta plus y sin theta. We know the value of x and y and all and theta. So substituting a x, y and theta, and we are getting the value u as 23.1 mm. Okay, and similarly for calculating the v coordinate, the formula is y cos theta minus x sin theta. Okay, so vice versa of u and v. Okay, so substituting y, x, theta and all, so we are getting the v value as 56.56 mm. Okay, so this is for point A. Similarly for point B, we have to calculate the coordinate x coordinate and y coordinate with respect to G only. Okay, so point G is here and point B is here. Okay, so for B, the x coordinate is same, minus 23, because G is ahead of B. So for point B, the x value will be minus, so minus 23.6 mm, and y value is for point B, the y value is minus 23.6. That is also minus, because for point G, the y bar is 23.6. So point B is at the base, so minus 23. So both the values are minus 23.6 mm. For point B, x bar is equal to minus 23.6. Similarly, y bar also minus, y is equal to minus 23.66 mm. So after knowing x, y and all, so we are calculating uv by using the formula x cos theta plus y sin theta for u, and for v y cos theta minus x sin theta, and substituting those values x, y, theta and all, we are getting u value as minus 33.45 mm and v value as 0. And next we are calculating for point C. So for point C, the x coordinate is, so point C is head of point G. Okay, so plus value will come. Okay, so total 80. So 80 minus 23.6. So for point G, the x bar is 23.6. So 80 minus 23.6. So we are getting the value 56.34. And y bar, so point C in y direction, point C is at the base. So G bar, y bar for G is 23.6. So for point C, the y value is minus 23.6. Okay, so minus 23.6. So substituting in U and V formulas and all, and we are getting U value as 23.1 mm and V value as minus 56.56 mm. So after knowing UV for point A, point B and point C and all, so we can calculate stress for point A, stress at point A, stress at point B, stress at point C. Okay, so we know the formula, stress calculating formula, M dash U divided by IVV plus M double dash V divided by IUU. Okay, so we know the M dash value 1.697 and M double dash also 1.697 into 10 power 5 Newton mm. Okay, so M dash and M double dash are same, so we are taking it as a common. Okay, M dash value is 1.697 into 10 power 5 into U value for point A, U value is 23.1 divided by IVV. So IVV value already we calculated, so IVV is 3.67 into 10 power 5 Newton per mm square, that we are substituting here, plus V value for point A, V value is 56.56 mm. Okay, divided by IUU. So IUU value also we already calculated. IUU is equal to 14.124 per 5 Newton mm per 4. Okay, so that value also we are substituting here, and we are after solving we are getting sigma A as 17.47 Newton per mm square. So stress at point A is 17.47 Newton per mm square. So after calculating stress at point A, so similarly we are calculating stress at point B by using the stress calculation formula, and we are getting sigma B as minus 15.47 Newton per mm square, and similarly sigma C also 3.8 Newton per mm square. Okay, so after calculating stresses, in the question they are asking deflection of the beam also. Okay, so we know the formula, deflection of the beam delta is equal to KWL cube by E into square root of sine square theta divided by IVV square plus cos square theta by IUU square. Okay, so I already gave this formula in the last video lecture. So K is equal to constant. So this is a simply supported beam, okay, with a point load at the center. So the end condition is a simply supported ends and point load is acting at the center. So K is equal to 1 by 48. Okay, so how this value 1 by 48 came means, the deflection formula we know for a simply supported ends and carrying a point load at center, deflection is equal to WL cube by 48 EI. So in the formula 1 by 48 is a constant, so we are taking that as a K value. Okay, and we know W value, L value, E value and all. Okay, IUU, IV and all. So we are substituting those values in the formula, and we are getting delta as 1.1466 mm. Okay, so after calculating deflection, okay, in the question they are also asking the direction with the load line, deflection of the beam at midsection and its direction. Okay, so deflection direction also they are asking. So deflection delta will be inclined at an angle beta clockwise with a line GV is given by, so tan beta is equal to, we know this formula, tan beta is equal to IUU divided by IVV into tan theta. So we know IUU, IV value and all, so and we are substituting theta value 45 degree and we are getting as 3.848 value. Okay, so therefore beta is equal to 75.43 degree. So thus the deflection is at 75.43 minus 48 is equal to 30.43 degree clockwise with a load line GY. Okay, so in diagram, so this is the delta U and this is delta V. Okay, so this one is delta. Okay, so this value only we are calculating as a 70 degree, 75.43 degree. Okay, 75.43 degree and minus 45. Okay, so this angle is 45 degree. So will gives this value, the angle value 30.43 degree. Okay, so deflection angle with the load line GY dash, with the load line GY, it is 30.43 degree. Okay, so after calculating the angle of deflection, okay, with respect to the load line GY dash, The last one is position of the neutral axis. In question they are also asking position of the neutral axis. So neutral axis will be at 90 minus 30.43 is equal to 59.57 degree anti-clockwise with a lower line, because the neutral axis is perpendicular to the line of deflection. Okay, so we know that the neutral axis will be perpendicular to the line of deflection, so we are using 90 minus 30.43 degree, so that will give 59.47 degree. Okay, so position of neutral axis at 59.47 degree, 59.57 degree anti-clockwise with lower line. Okay, so that's it. And the question they are asking stresses, deflection and position. So all these things are all we calculated. Okay, so thank you.